Let's discuss the tools and techniques of this process. The tools and techniques include data gathering, data analysis, decision making, data representation, audits, design for X, problem solving, and quality improvement methods. A data gathering technique that can be used for this process includes checklists. A checklist is a structured tool, usually component-specific, used to verify that a set of required steps have been performed or to check if a list of requirements has been satisfied. Based on the project's requirements and practices, checklists may be simple or complex. Many organizations have standardized checklists available to ensure consistency in frequently performed tasks. In some application areas, checklists are also available from professional associations or commercial service providers. Quality checklists should incorporate the acceptance criteria included in the scope baseline. Data analysis techniques that can be used for this process include alternatives analysis, document analysis, process analysis, and root cause analysis. Alternatives analysis technique is used to evaluate identified options in order to select which different quality options or approaches are most appropriate to use. The analysis of different documents produced as part of the output of project control processes such as quality reports, test reports, performance reports, and variance analysis can point to and focus on processes that may be out of control and may jeopardize meeting the specified requirement or stakeholders' expectations. Process analysis identifies opportunities for process improvements. This analysis also examines problems, constraints, and non-value added activities that occur during a process. Root cause analysis is an analytical technique used to determine the basic underlying reason that causes a variance, defect, or risk. A root cause may underlie more than one variance, defect, or risk. It may also be used as a technique for identifying root causes of a problem and solving them. When all root causes for a problem are removed, the problem does not recur. A decision-making technique that can be used for this process includes, but is not limited to, multicriteria decision analysis. Multicriteria decision-making is used to evaluate several criteria when discussing alternatives that impact project or product quality. Project decisions can include choosing among different implementation scenarios or suppliers. Product decisions can include evaluating the lifecycle cost, schedule, stakeholder satisfaction, and risks associated with resolving product defects. Data representation techniques that can be used for this process include affinity diagrams, cause and effect diagrams, flowcharts, histograms, matrix diagrams, and scatter diagrams. Affinity diagrams can organize potential causes of defects into groups showing areas that should be focused on the most. Cause and effect diagrams are also known as fishbone diagrams, Y-Y diagrams, or Ishikawa diagrams. This type of diagram breaks down the causes of the problem statement identified into discrete branches, helping to identify the main or root cause of the problem. The figure in front of you is an example of a cause and effect diagram. Flowcharts show a series of steps that lead to a defect. Histograms show a graphical representation of numerical data. Histograms can show the number of defects per deliverable. a ranking of the cause of effect, the number of times each process is non-compliant, or other representations of project or product defects. The matrix diagram seeks to show the strength of relationships among factors, causes, and objectives that exist between the rows and columns that form the matrix. A scatter diagram is a graph that shows the relationship between two variables. Scatter diagrams can demonstrate a relationship between any element of a process, environment, or activity on one axis and a quality defect on the other axis. An audit is a structured, independent process used to determine if project activities comply with organizational and project policies, processes, and procedures. A quality audit is usually conducted by a team external to the project, such as the organization's internal audit department, PMO, or by an auditor external to the organization. Quality audit objectives may include identifying all good and best practices being implemented, identifying all non-conformity, gaps, and shortcomings, sharing good practices introduced or implemented in similar projects in the organization and/or industry, proactively offering assistance in a positive manner to improve the implementation of processes to help raise team productivity, and highlighting contributions of each audit in the lessons learned repository of the organization. The subsequent effort to correct any deficiencies should result in a reduced cost of quality and an increase in sponsor or customer acceptance of the project's product. Quality audits may be scheduled or random and may be conducted by internal or external auditors. Quality audits can confirm the implementation of approved change requests, including updates, corrective actions, defect repairs, and preventive actions. Design for X is a set of technical guidelines that may be applied during the design of a product for the optimization of a specific aspect of the design. Design for X can control or even improve the product's final characteristics. The X in the design for X can be different aspects of product development, such as reliability, deployment, assembly, manufacturing, cost, service, usability, safety, and quality. Using the design for X may result in cost reduction, quality improvement, better performance, and customer satisfaction. Problem solving entails finding solutions for issues or challenges. It can include gathering additional information, critical thinking, quantitative and/or logical approaches. Effective and systematic problem solving is a fundamental element in quality assurance and quality improvement. Problems can arise as a result of the control quality process or from quality audits and can be associated with a process or deliverable. Using a structured problem-solving method will help eliminate the problem and develop a long-lasting solution. Problem-solving methods generally include the following elements: defining the problem, identifying the root cause, generating possible solutions, choosing the best solution, implementing the solution, and verifying solution effectiveness. Quality improvements can occur based on findings and recommendations from quality control processes, the findings of the quality audits, or problem solving in the managed quality process. Plan to do, check, act, and Six Sigma are two of the most common quality improvement tools used to analyze and evaluate opportunities for improvement.